Today we're going to be performing a teardown of this SMC 18-inch oscillating stand fan. This is the SMC oscillating stand fan model SR-18. And the purpose of this teardown is to see if we can determine what the source of the hazard is in relation to the recall. I wanted to do this video in a couple of weeks because I wanted to give my voice some time to return to normal from this dumb everlasting cold, and I wanted to dig through my collection and pull out a bunch of different models that span different sizes and different years. I have a good number of these from the 90s all the way through a couple years ago, because there are descendants of this still under manufacture, not in this particular size but in the smaller form factors. And so I wanted to get all those out and compare different sizes, different years, different models to the design of this one. But we can still do that, but I want to nip this in the bud before it gets too out of hand. One of my pet peeves is inaccuracy, and unfortunately there has been a lot of inaccurate information spread about these fans. There was a recall issued in, I believe it was 2004, that says these fans are a fire hazard, and of the 2.2 million that were sold here in the United States, there are, I think, less than 40, it was like 36, 32, somewhere in there, reports of, like government documented reports of failure. The recall provided by the CSP, I think it is, whatever that government agency is that issues the recalls, I don't remember what the abbreviation is, but those recalls, the recall it put out, is very vague, as those tend to be, and it does not describe what the actual failure is with the fan. It just says that there's some kind of hazard with the cord, which could be a number of different things. You could have a wire that flexes internally and the insulation breaks off internally and shorts out. You can have a wire that moves against a junction and then it breaks at the end, or it frays and then it shorts out. You can have a wire that scrapes up against something and over time the insulation wears out and shorts out. It could be many different things. There are a good number of people going around, and I don't know where this originated from, so this video is not an attack at any particular person. It's an attack at the problem, which is inaccurate information. There is a lot of people saying that if you wrap the wire in electrical tape, everything's fine. I just don't think that that's true. There's also a fixation on the metal hoop that can be seen in the video from DPI, I think was the company that put the video out. And there's a fixation on this hoop being the problem. But if the video from DPI is accurate, then there should be no hoop inside this fan. And that means the hoop is not the source of the recall. The hoop might be a bad design, but it's not the source of the recall. So we're going to go into this fan and we're going to do a teardown. We're going to look at everything inside there, look at the wiring, look at the motor. We'll turn it on with the cover removed, see how stuff moves around, and see if we can find out what the potential hazard is. Now, some of the things I say in this video are going to be factual, and some of the things I say in this video are my theories, my hypotheses, and I'm going to be very clear as I switch back and forth in conversation as to what I'm talking about at that particular time, be it a known fact or a hypothesis, because we should not take theories and just accept them as true and blast them out as known information, especially when it comes to matters of health and safety. In fact, just to go on a quick tangent, I think a lot of the problems that we have today are the result of people when asked a difficult question, not saying, I don't know, we need to either collect more information, get more experience, etc. Instead, people just poop out an answer just to have something to say, and it's a bad answer, and it's wrong, and it results in a problem. It's not good. I have a lot more respect for people that just say, I don't know, when they really don't know, as opposed to just making something up. So, and to that point, I don't really know what the answer is to this. I'm going to try to find out, but at the end of this video, I still don't know. And I may never know because for whatever reason, this information, when there's a safety issue, is kept as a secret from the general public, which I honestly think is really annoying. Alright, so as we take this apart, everything so far looks to be very standard. Here's something that's concerning to me, and this is a standard concern I share amongst many fans. This is all plastic, including the threads. These look to be fairly strong. The threads look like they're in decent condition, but there's a possibility that if the shaft gets hot over time, or if this is put on cross-threaded, etc., that this could come loose. The blade could come loose and the shaft can spin inside the blade, leaving the motor with no cooling. That's a possible, and this is my speculation, that's a possible failure mode. Not specific to this model. I've seen a lot of fans like that. It does have a slot here that the shaft lines up with, but if the shaft moves just a couple millimeters, or should I say the blade moves a couple millimeters forward, it's not going to grab that slot, and then it could potentially just spin on the shaft. Excuse me. Alright, so proceeding further, this looks like a very standard SMC or Midea product. Looks the same, this comes off the same. This is all standard so far. There's no signs of this getting particularly hot in here. The plastic is not yellowed around the front of the motor or anything of that nature. This is also a very standard design. The motor does look kind of small from the outside. This is a 0.7 amps motor, so I would expect it to be fairly large. Probably not quite on par with the old Lasco Galaxy oscillating 16-inch fans, but you know, kind of in that territory. After all, this is an 18-inch model, so it's bigger. Okay, the screws are all standard. Next we have these clips, which are also a very standard design amongst these SMC fans. These are kind of a pain to work with. Usually you pull this out and you can push it in. There we go. I don't know why that wasn't working properly before. Oh wow, that's a tiny little motor. So there's no signs of this getting particularly hot. This is not yellowed or anything. I think that this has a reasonable number of hours on it. It's used for a couple of seasons at least, based on the dust accumulation. Alright, so here we are inside the motor housing here. This is our lead wire that people are freaking out about. Let's remove the screw from the oscillator knob. And here's what we have inside. I also want to take off the back of this switch housing here and see if there's anything weird going on inside this area. because we know that this plastic is flammable. Now I don't know if the motor housing plastic is flammable as well or not. The video from DPI does show this can take a pretty hot flame, but it's obvious that these are two different types of plastic. If these are the same types of plastic, the yellowing should have been very similar, and it's not. I don't know how this comes off of here. This is probably very brittle, so I don't want to force anything. Okay, that works. So we can see inside, this is the original color that was not exposed to the sun or whatever moisture in relation to the outside color. So this is a very lousy material that this was made of. Okay, so nothing crazy in here either. Looks like a standard rotary switch. Looks like a standard permanent moret, whatever those are called. And then we have a plastic clamp holding the wire in place. So this is a potential flex point here where the wire can move as it oscillates. And looking at this design, there should be no movement past here or down. Should be the same, always in the same place. This is pretty tight. If I push this down here like this, it doesn't move on the other side really. That's not pinching the wire, that's just insulation that's pinched over there. I don't like this. I don't like it at all, because you have electrical connections, you have a switch that could potentially arc, all encased in flammable plastic. Unfortunately, that's standard nowadays. It's been standard for some time. I don't like it, but it's no worse than any other fan of this style from this era that I've worked on. Alright. In the motor area, here's the infamous lead wire. So, there is no hoop. And the hoop I'm talking about, and this is why I wanted to get some of the other fans out. Later on, a metal hoop was added over here, or maybe it was within this screw, I think. And it secures the wire up against the motor and holds it in place kind of like that. And I believe, and this is my theory, I believe what the hoop does is it changes where the flex point is located. So right now, let's disengage the oscillation. Right now, it looks like the flex point is actually right around here. This is where there seems to be a lot of flexing, and then right down there. Is it possible that the wire is scraping up against this side here? It is. This is very dull. I think it would take millions of oscillations to actually cut through it. We inspect this wire here. I'll try to turn the insulation around. There's some dirt there, but it's not cut. It's just dirty. There is no trace of the wire having been cut through or anything like that. There is a little bit of like an indent down here, and this is where we might need to put the housing on and see if we can watch it work. There's a little bit of indentation here. This is a possible area of concern, but I don't even see where that would have been touching, because unless that did not move up or down. I don't see where that would have been touching, because if you look at it from this angle, that is above or rather that's below where it would touch anything, so that doesn't even make any sense. Let's put the cover back on, the motor housing cover, and let's turn this fan on and let's observe how it works. And that's a good starting point. Put the oscillation on and let's see what it does. Now, if it happens to catch on fire during this video, that would really be something. Alright, so this is in place as best as it can be with maintaining the visibility. Let's see what it does. Yeah, the flex point is down here. That's where it's flexing a lot. So there's nothing concerning going on right now. Let's see, can we reorientate this? Kind of just push I don't know where this would have, where this falls in every single fan. Let's say we jam it in the back like that. Okay, I can hear the wire scraping up against something right now. And I can see it moving on the top a little bit. But I've heard so many oscillating fans make that noise. I don't like this. I don't like this design, but this is very, very standard. There are so many units designed like this, and as much as I don't like it, I think it's dangerous. It's common. The only marks I can see on the wire are down here, and this is below. I can't make that touch any part of the motor, so that must have been something during assembly, I guess. Unless, could it be, no, it wouldn't be that. Is that actually, is it just dirty? I don't know. I think it's mostly just dirt, actually. Yeah, I don't see how that could, if it was scraping up against here, we'd see a problem right here. And we don't. We don't really see anything anywhere. That's just dirt up there. It's not rough at all. I really just, I don't see how the wire could be a problem. This is a very typical standard design. The only thing I can think of that would be a problem is maybe up here. Oh, I just saw another problem. We'll get to that in a minute. It does seem like this is a flex point here. And since this is kind of a delicate area where the wires go into the windings and make a connection, I can see potentially that it might be able to work its way loose and short out up here. I think that's a possibility. That's my speculation. That's not proven to be the case. Again, the official recall notice simply says that there's something wrong with the power cord, or the, I don't know, they say power cord or head wire or something like that. There's a problem with the wire where the wire can short out. It doesn't say how. It's possible that the wire could short out in here. The insulation could wear off and crack off, and then the conductors can short out and just do it all by himself just from the flexing. I don't know. I don't personally see a problem with this. This is standard. I don't like it, but it's standard and it's pretty widely proven to not be a problem. Here's a problem. And I think that I might have just figured out why this is dangerous. This says, up here, it says, wow, that's already a little bit warm. This says 133 degrees. Oh, before we get to that, one more thing I wanted to look at: the capacitor. The capacitor is only 4 microfarads. That's pretty reasonable. There is some speculations that go around that say that in regards to the TH12 and the TH16, some people say that the TH16 uses the same motor as the TH12 but with a higher value capacitor, and then it burns out. I thought that might be the case here, but it's not. 4 microfarads is pretty reasonable. So this says 133 degrees Celsius fuse. That is way too high. If we assume, and that is kind of a dangerous thing to do, but if we assume in this case that this is a Class A motor, and I really can't fathom that a fan of this caliber would have anything other than a Class A motor. If we assume that this is a Class A motor, the insulation in the windings is good for up to 130. No, that's a Class B. A Class A is 103. Yeah, I think 103. A Class A is only good for 103. And if we look at this wire here, this wire says 105 degrees Celsius. So maybe I've got the, maybe it's 105. I don't know, it's right around 100 degrees Celsius is what Class A is good for. And this fuse is for 133. So it's about 30 above what the insulation inside the motor and the wiring is able to handle. Now, even if this was a Class B motor, which I really don't think it is, if it was a Class B motor, Class B is only good for 130, so it's still wrong. 133 versus 130 is a huge discrepancy. 133 degrees Celsius is very, very hot. I think that's almost approaching 300 degrees Fahrenheit. That's extremely hot. And so the danger here is that the thermal fuse is potentially allowing the motor to operate at a temperature above what the insulation is designed to handle. And so what can happen is if the motor happens to run very hot, the insulation in the windings can break down. If this is sitting up here against a stator that's 100 and something degrees Celsius, this can break down, and then this can short out from the heat decay. A standard thermal fuse for a Class A motor is around 90 degrees Celsius. This is ridiculous. So that in and of itself right there is a serious hazard, because the thermal protection in this is not going to work. That thermal protection fuse is not going to cut it off before the motor reaches a dangerous temperature. That is extremely concerning to me. So I actually think that that might be our answer. And again, this is my speculation, but I wonder if this motor runs so hot that it just, in certain circumstances, with an oscillating fan, it's particularly dangerous to have motor overheat conditions that are not correct, or motor protections that are not correct, because if you have the fan in oscillation mode and the oscillation jams, or the fan tips over and the oscillation gets stuck, the gears will slip because they're just cheesy plastic gears, but it's going to slow down the motor considerably and reduce the airflow, and the motor's going to overheat. I've repaired a lot of oscillating fans over the years that broke, that the thermal fuse went out because the fan tipped over while in oscillation mode and it got partially locked up. If one of these was to tip over, or whatever condition exists where the oscillation gets locked up and the motor gets near a stalled condition and heats up, this is not going to cut it off before there's a serious problem. So I wonder if maybe, my theory here is that maybe the motor simply runs so hot and the thermal protection is inadequate that in the event that something does go wrong, the motor breaks down and literally burns out instead of being caught by the thermal fuse. And motors burning out like this kind of just on their own is extremely rare, because the thermal fuse should stop that from ever happening, but this thermal fuse will not. So maybe what we need to do is we need to stick a thermostat probe in here, put it back together, and let it run and see what kind of temperature it runs at, and then maybe lock it up under very closely supervised conditions so we don't damage it. Maybe put something in the back of the motor that blocks the airflow to simulate it being clogged with dust, etc. And just kind of create some conditions where the motor could potentially heat up to dangerous levels, and just see how hot it really gets, because that fuse is certainly not going to cut it off. So in my opinion, that fuse is about 40 to 45 degrees Celsius higher than it should be. So I'm gonna bet that that's our problem. I'm gonna vote on it being a thermal problem, and that there's not really an issue with this. I don't like this. I don't like wires flexing, but this is a standard design. There's nothing unusual about this. And the fact that the hoop was applied would kind of support the fact that this is maybe a flex issue here. Because I tend to think that the hoop, and we can look at the other ones to confirm, but if the hoop just locks it in place, it only stops this from flexing. So maybe this is a flex point and it breaks there. Maybe the motor can get too hot and the insulation breaks down and the wire shorts out for that reason. I don't know. Those are going to be my two hypotheses here, and one or the other: thermal, or that's your flex point problem. If those two things are the case, I think that one of those two is going to be the case. I don't know. I can't prove it at this time. I think what you'd have to do to make this safe is a couple things. Number one, I think that thermal fuse should be replaced with a 90 degrees Celsius thermal fuse. And then I think the other thing that you should do is connect a fused plug, because if you have a fuse and something happens where, let's say, this wire somehow wears down and it wears down to the point where the copper, alloy, aluminum, whatever the heck it is, touches the housing, touches itself and shorts out, fuse will cut the power immediately. Or if the wires break up here and it shorts out up there, the fuse is going to open immediately, whereas your dumb circuit breaker probably will keep supplying power until there's a problem. That's one of the reasons why I think fuses are superior to stinking circuit breakers. Yeah, I think better thermal protection and a fuse plug would probably alleviate the majority of the concerns that I would have about this. Should you strap this in a bunch of electrical tape? No, I don't see any reason why you should. Electrical tape degrades with heat. It's going to get sticky and melt off. It's not that strong of a material. If the chafing is strong enough to cut through this, which is PVC, it's definitely going to cut through electrical tape. If anything, you're just buying some time doing that, assuming that's the problem. And I really don't think it is. I don't think that this is an issue. I don't see... Now, could this have only been used in stationary since it was bought? Yes, that's a possibility. I don't see any damage to the wire, other than that one part down at the bottom, which I really don't... It's got to have been a manufacturing defect, because... or an assembly defect, because I can't see... That can't physically make contact. The contact point's over here, and there's no marking on there. I don't know. I don't have a formal, provable, proven answer on this, and I don't think we ever will, because the information is a secret. But that's my speculation. I think it might be a short at the flex point where it goes into the motor, or more likely, I bet it's just a thermal issue. You know, if it's really cheap plastic, and the insulation on the, cheap plastic enough to catch flames at almost 300 degrees Fahrenheit, which is not inconceivable, or insulation here that's melts at 105 degrees Celsius and exposes wires. That's very, very, very possible as well. So I don't know. Interesting stuff here. I was not expecting to see that thermal fuse be off the charts like that. That is totally unacceptable, and I really think that is going to have something to do with it. So we're going to revisit this in the future. I'm going to get a whole bunch of other models, some stand models, some tabletop models, some sold under different brands. We're going to compare the motor design. We'll see some with the hoop, probably some that don't have it. We'll check for any kind of wear marks. Is the hoop dangerous? Possibly. I know my mother had bought a Hawaiian Breeze branded oscillating fan in the early 2010s, which is an SMC or Midea product. And it has the same design. It's got the hoop. And that thing has a ton of hours on it. And I remember when I went to clean it once, I noticed that design with the hoop, and it did seem like there was an indent where the hoop was. Again, I think you would have to pick probably millions of oscillations to actually cut through it. But I wonder, in that case, maybe the answer for the hoop is just to clamp it down. Clamp it down so that the wire can't move inside it. I don't know. We'll look at that when we look at with the hoop. In fact, there's a good shot that that fan is pretty much the same inside as this one, and that might have the hoop. But that is an exploration for another time.